Hi everyone, this is your lesson 3 video. So we're doing some more on straight line motion, and now we're looking at tables and graphs. These notes are on page 13 of your packet. If you could make sure you're there, that would be great. We've got one learning objective, which is calculate rates of change in applied context. So again, we're doing the same thing we did in lesson 2. It's just that now we're doing it with tables and graphs instead of just strictly with functions. So for question 1, we're going to be looking at a table of a velocity function. Tina's completing a 50-minute training run on a straight path to prepare for her upcoming marathon. Her velocity is given by a differentiable function v of t, where v of t is measured in meters per minute and t is measured in minutes, and we've got selected values of v of t in the table here. Part A asks us to estimate Tina's acceleration at time t equals 10 and indicate proper units in your answer. So the key word here is that we need to estimate her acceleration. So remember that acceleration is the rate of change of velocity, which means if we have a table that has velocity, in order to estimate the acceleration, we're going to just use average rate of change. That's going to be our estimate. So we need to focus in on something that's around 10, which means we're going to do between 5 and 15, which means we're going to say that the acceleration at 10 is approximately equal to the velocity at 15 minus the velocity at 5 all over 15 minus 5. And now if we go ahead and plug in, let's see, we'd have 220 minus 170 all over 10. So let's see, 220 minus 170 would be 50 over 10. And so we get that the acceleration at 10 is going to be approximately, what did I say, 50 divided by 10, which is 5. And now we need to think about those units. Well, the velocity was in meters per minute, and then time is in minutes. So we would have meters per minute, or you could say 5 meters per minute squared. Either one would be fine. But this is our approximation for the acceleration at 10. Now, part B asks, must Tina have switched directions in any of these subintervals indicated by the table? So the thing we want to think about is if we want to talk about switching directions, it means that the velocity changes signs. Because we know she's moving to the right if she has a positive velocity and to the left if she has a negative velocity, which means she switches directions anytime the velocity changes signs. So we need to look at our answer or at our table here and decide if that ever happens. We can recognize that somewhere on this interval between 15 and 32, we went from a positive velocity to a negative velocity. And somewhere on this interval between 40 and 50, we went from a negative velocity to a positive velocity, which means yes, Tina must have switched directions. So we can say yes, Tina switched directions somewhere on the interval from 15 to 32 and the interval from 40 to 50. And we do have to justify here. So because v of t changes signs on those intervals. So again, she switched directions any place where the velocity changed signs. And so we look for where did we go from positive to negative or negative to positive in terms of the velocity. All right, the second part here, we're going to analyze the graph of a velocity function. So we have a particle moving along the x-axis. We've got the velocity here for the graph. We notice that the y-axis, the y-axis is the velocity, so this is the velocity graph. Velocity is 0 at t equals 0, 3, and 5, and the graph has horizontal tangents at t equals 1 and t equals 4. Now for part A, it says, for the interval from 0 to 5, is the particle speeding up or slowing down? We know that in order to determine that, we have to look at both the velocity of the function and we have to look at the acceleration of the function on that interval. So we're going to make kind of some notes here before we make our final answer. So we know that for the interval from 5 to 6, if we look at our velocity function here, we're looking right here along this interval from 5 to 6. Well, this is the velocity function, and that's below the x-axis, which means the velocity on this whole interval is going to be negative. And the reason we know that, right, is because we're below the x-axis. So we're just kind of making some notes here of how do we know this and what do we know. All right, well, let's think about the velocity. We know if we've got, the acceleration. If we have the graph of velocity, we know that the slope of v of t is going to be the acceleration, because acceleration is the rate of change of velocity. So when we look along this same interval here, the slope along that interval is going to be negative because the function is decreasing, which means that along the interval from 5 to 6, the acceleration is also negative. And that's because the slope of v of t is negative. Well, when we look at this then, we've decided the velocity is negative and the acceleration is negative. Those are the same sign. And so we would say then that the particle is speeding up. Speeding up because v of t and a of t have the same sign. Oops, really bad H. Have the same sign on the interval from 5 to 6. All right, last part here, part B. During what time intervals, if any, is the acceleration of the particle positive? And we want to justify our answer here. So again, we are looking at the slope of the velocity because we know that acceleration is just v prime of t. Well, we were already told up here that the function has horizontal tangents at 1 and at 4. That means at x equals 1 and at x equals 4, the slope is 0, right? There's my little tangent lines. Well, from 0 to 1, my function is decreasing, which means I have a negative slope. Then from 1 to 4, my function is increasing. I have a positive slope. And then from 4 to 6, my function is decreasing. I have a negative slope. So in part B here, I'm looking for where is the acceleration of the particle positive, which means I'm really looking for where the function has a positive slope, which is right there. And so we're just going to make a quick note of that for future reference. Acceleration of the particle is positive. We know that acceleration is v prime, and so we're looking for where is v prime positive. So let's see here. What did we decide then? This would be the interval from 1 to 4. 1 less than t less than 4 because acceleration, which is really v prime of t, is greater than 0 on this interval. And there we go. That is our answer. If you had any questions, please make sure you wrote them down. I will see you back in class for some practice. Thanks so much for watching.